Hello students. So today we will do one problem based on this circuit. Okay. So the questions are asked giving this circuit. Okay. Uh, so the first question which is asked is identify the given circuit. State one use of it. Okay. So by looking at this, you'll identify it as a full wave rectifier. Correct. Two diodes are connected here. This is a transformer and this is called a central tap transformer. Okay, this is a load resistance. So we put the input and we get output, right? So this is a full wave rectifier. So answer for this is full wave rectifier. Okay, now we have to write one use of it. So one use of it. What is the use of a rectifier? Rectifier is a device which converts AC to DC, that is alternating current, it converts to direct current, right? So it converts AC to DC. Okay. Now the second question is which end of the secondary of the transformer? This is primary, this is secondary. Okay. This is a primary coil, this is a secondary coil. Should be positive with respect to the center tap to forward bias diode D2. Okay, now you should know one thing, that is when the positive first cycle, that is half cycle, is there, that time A becomes positive and B becomes negative. Okay, so when A becomes positive, D1 is forward biased. Okay, so the current flows through this. Okay, and we get a output. And this D2 is reverse bias, so there is no conduction of current here when it is a positive half cycle. Okay. For the next negative half cycle, D1 becomes negative and D2 becomes positive. Okay. That time D1 is reverse bias, so there is no conduction of current here. Okay. For negative half cycle, D2 becomes positive, so there is a conduction of current here. So we get a output. Okay. So the question is which end of the secondary of the transformer should be positive with respect to the center tap to forward bias diode D2. So to forward bias diode D2, we have to connect the positive end to the secondary of the transformer. Okay, that is B point. Okay, so end B. Okay. How does the output voltage change if the amplitude of the input voltage is increased? Now, if the amplitude of input voltage is increased, the output also increases. Okay. Okay. Draw the output waveform for the above circuit. So, output waveform, first you have to draw the input waveform. Okay. Now, this is positive half cycle, then the negative half cycle, positive half cycle, negative half cycle. Okay. This is the input. Then we get a output. Okay. So, we get this. Okay. So, for negative half cycle we get output, for a positive half cycle also we get output. That's why it is called full wave rectifier. Okay. Now this is a waveform. For a positive, fifth question, for a positive half cycle of the input sine wave, both D1 and D2 do not conduct simultaneously. Why? Now the answer is same, that is for a positive half cycle. Okay, you have to write like this. For a positive half cycle, this is fifth question. Positive half cycle implies that A is positive and A is positive. So D1 is forward biased. Okay. And D2, where B is negative, D2 is reverse biased. So we can say that D1 conducts and D2 does not conduct. Okay. Next is state the type of transformer used in the circuit. This is center tap transformer. Okay. Then does the voltage between the points A and B have steady value? No, it doesn't have steady value. Okay. And we get it's a pulsating this thing output. It's not a steady output. Then sometimes capacitor is connected in parallel across the load resistance RL. So here the capacitor is connected. Okay. Why? Capacitor acts as a filter. Okay. Because we are getting a pulsating DC voltage. That is, we are not getting a steady DC current. Okay. That's why we uh, uh, take here capacitor, that is capacitor is connected. This capacitor filters it and we get a steady output DC voltage, okay, or a DC current. So this you can write it as capacitor acts as a filter. Okay, we get pulsating DC output. So to get steady DC output, we connect capacitor in parallel with RL, that is load resistance. Okay. Then which side of the diodes is connected to secondary of the transformer? So as you can see here, secondary is here. So the connection is here to the diode. So diode is nothing but like this. Correct? This is a P type semiconductor. This is N type. So P part is connected to the secondary of the transformer. Is it possible to design same circuit for same output without using center tap transformer? So there is one more way, okay, without using center tap transformer, that is we use bridge rectifier. Okay, in that they use four diodes. Okay, same circuit is there, but they use four diodes. That is called a bridge rectifier. Okay. Now there is one more thing I want to add here, that is when you look at the input, okay, this is positive half cycle, this is negative half cycle, again positive, again negative. But for the output, you will get the positive value only. Okay, this is because the direction of the current, okay, that is through RL. For both the half cycles, it flows from right to left. The output during both the half cycles will be of the same nature. Because, now look here, when it is a positive half cycle, current flows like this. Correct? From here to here. Okay. Now for the negative half cycle, it flows from here to again here. That is for RL, the direction of the current remains same. Okay, so that's why it is positive. The waveform is positive here. Here for both is there, negative, positive. Okay, so the correct sentence is like this: current during both the half cycles flows from right to left. Okay, through the load resistance RL, the output during both the half cycles will be of the same nature. Okay.